Hi, in this video we'll take a look at some rules for calculating derivatives. This is a lot more algorithmic. Don't worry if you don't get the rules at the beginning. It's a matter of practice. The first rule we will look at is the power rule. The power rule tells us that if f of x is equal to x to the n, the derivative f prime of x is n times x to the n minus 1. So you see here the exponent goes down as a coefficient now, and it is reduced by 1. The next rule is called the constant multiple rule, and it tells me that if a function f of x, or let's say g of x, is a constant multiplying a function f of x, then the derivative of the function g is c times the derivative of x. So that means that the constant doesn't affect the derivative, so you just calculate the derivative of the original function and ignore the number that is in front of it. Ignore the coefficient. The next rule is called the sum rule. So if I have functions f and g, f of x plus g of x, then the derivative of their sum is equal to the sum of their derivatives. Prime of x. Oops. And I actually can replace the plus here with a minus, so that tells me that the derivative of the difference is the difference of the derivatives. Our next rule is called the product rule, and it states that if we have functions f and g, then the derivative of the product f of x times g of x is equal to f prime of x times g of x plus g prime of x times f of x. We have also a rule for the quotient, so if we have f of x divided by g of x, then the derivative is given by f prime of x times g of x minus g prime of x times f of x, and all divided by g squared of x. Yeah? It's a little bit more complicated rule, but again, with practice, we'll be having no problem with that. And finally, a list of the derivatives of special functions that sometimes will appear in practice, like the exponential function, the natural logarithm, sine, cosine, and tangent. You don't need to memorize those. You can have them around. With practice, anyway, you will end up memorizing them. The derivatives have some application in economics. As we said before, the marginal cost, which is defined, marginal cost of producing q items is defined as the total cost of producing q plus 1 items minus the total cost of producing q items. And this is often very similar to the derivative of the total cost function. In a similar way, the marginal revenue of selling q items is the difference between the total revenue of selling q plus 1 minus the total revenue of selling q, which is approximately the derivative of the total revenue function at point q.